Okay, in part 2 of our Tower of Hanoi discussion, we came up with an explicit formula in addition to the recursive formula for the Tower of Hanoi problem. Notice what I'm doing here is I'm doing the Tower of Hanoi problem that's in both section 5.6 and 5.7. If we wanted to prove this property using mathematical induction, look at what we're doing. We're supposing that this sequence, move 1, move 2, move 3, and so on, which we found was defined by the recursive formula, moves for this many disks, sub d, is equal to 2 times the number of moves previously plus 1, and this formula would work for all the disks starting at 2, and then we would make our initial case the first move only took 1. What we want to prove is that this explicit formula, moves sub d is equal to 2 to the d minus 1, and that would be true for all of the d's starting at and are greater than 1. We want to prove that that explicit formula works. We're going to do this proof by induction. Well, first of all, how do I know I'm doing it by plain vanilla induction as opposed to strong induction? Well, let's see. We only have one initial case. That's one good hint that it could be regular induction. The second hint is we're only looking back 1. We're not going back any further than 1. So we can do this with simple, straight induction. Our basis step, the initial case, the seed, if you will, is when we have one disk. Now, if I look at my recursive formula, well, it's given to us what that's going to be. It's going to be just one move. If I look at the explicit formula and I try working with one disk, I'm taking 2 to the first minus 1. So it's 2 minus 1, or 1, and these two things give us the same result, so we know that our basis step works. Alright, we're now ready for our inductive step. In our inductive step, we're going to assume that this explicit formula works for some k. In other words, that m sub k is equal to 2 to the k minus 1. We need to show that it's going to work for the next one. In other words, we need to show that m sub k plus 1 is equal to 2 to the k plus 1 minus n. We're going to do this with an interesting way of doing substitution. It's the way we do substitution on all the recursion problems, including, as a hint, number 6 in the homework with the proofs 2 set. Now, m sub k plus 1, if we use the recursive formula, you see it's going to be 2 times m sub k plus 1 minus 1. So it's 2 being multiplied times this thing plus 1. In other words, this is, let me write it down here, this is 2 times m sub k. K plus 1 minus 1 is m sub k. Okay? That's using the recursive formula that we started with on this. Well, wait a minute. We just assumed that m sub k is going to have a particular value. It's going to have the value of 2 to the k minus 1. All right? So let's put that in. In other words, I am taking this and substituting it in here. Now if I multiply that out, look what I have. 2 times 2 to the k minus 2 times 1 plus 1. 2 to the first times 2 to the k is 2 to the k plus 1. And what I have is minus 2 plus 1. In other words, I have 2 to the k plus 1 minus 1, which is what I needed. I have 2 to the k plus 1 as the exponent, minus 1. And that's what I needed to show. So I've done that. So what I have is, so by math induction, we know that the number of moves sub the number of disks is 2 to the number of disks minus 1 for every disk greater than or equal to 1. We have proven that that explicit formula works in all cases. That means instead of having to write a recursive formula for this, we could put in one line of code that does this operation, and it'll solve the problem much faster. You can always do this in writing code. You can often do this, I should say, when you're writing code, because you are many times able to make a recursive formula into an explicit formula. Not all the time, but many times. But if you're going to do that, you have to really be able to prove that your explicit formula is going to work the same way. And the way you're going to do that is with mathematical induction.